Okay, so same directions, guys, as the last video. So we're going to use, or first it says to give two phrases that are synonymous with the derivative of a function at a point. Well, the derivative is the same as the slope of the tangent line, which is the same as the instantaneous rate of change. So that's what I've written here for part A. Now for part B, just like yesterday, it says to use the limit definition of the derivative to find a function that will give the instantaneous rate of change of the function below at any given point. Okay, so so for part B, we're going to use that formula. So f prime of x equals the limit as h approaches 0. All right, so this is all going to be over h. And in the numerator, what's going to go first, or here's, what's going to go first is f of x plus h. So this is f of x. So what I want is where this x used to be, I want to put an x plus h instead. All right, so that's f of x. I'm just trying to save room. Yeah, so this is going to be 5. This is going to be 5 over. Instead of an x here, I'm going to put an x plus h. Or actually, I'll go plus 1. All right, so there used to be an x here, and now I want to put an x plus h there. X plus h. Now, I was going to leave a blank parentheses there, but I wanted to save room. You don't need parentheses around this x plus h because there's nothing being multiplied in front of the x. All right, so we wouldn't have really needed the parentheses anyway, and I just wanted to save room. All right, and then this is minus f of x is 5 over x plus 1. Alrighty, and then just like before, you try to direct substitute, which in this case we'd be plugging 0 in for h, because it's h that is approaching 0. So we'd put a 0 in there and we put a 0 in there, but that's a problem because we don't want a 0 in the denominator. So this is where you open up a blank limit and then you do an aside. All right, so I'm going to do this aside. So I'm taking the input of the limit, which is 5 over x plus h plus 1. Plus 1. All right, and the least common denominator, for the least common denominator, I need a factor of x plus h plus 1, and then I also need a factor of x plus 1. So that's the least common denominator. Oh yeah, and then this is all over h. And I'll put it over 1 now because we're going to want to do keep, change, flip. So in this denominator, I'm missing a factor of x plus h plus 1. X plus h plus 1. And then in this denominator, oh, kind of dark. And then in that denominator, I'm missing a factor of x plus 1. Okay. Now I've got to do some distributing. All right, so there's that fraction bar, h over 1. All right, so now, all right, so I got x plus 1, x plus h plus 1. And now in the numerator, I'll distribute things. So I'm going to have 5x plus 5 minus 5x minus 5h minus 5. Right. And you could cancel things like as you go. These, oh, this is great. So this 5x, those 5x's will cancel, and the 5's will also cancel. And then we can do keep, change, flip. So we're going to keep the top fraction, which is negative 5h over x plus 1. Change, flip. Okay. Multiply straight across. And then this is x plus 1, x plus h plus 1 times h. You wanted that h to cancel. All right, it was this h that we wanted to cancel. And then this h ends up right there, and it does cancel. Okay, we got it. Those cancel. So now you're done with your aside. -5 over x plus 1, x plus h plus 1. And now you can direct substitute. So it's going to be -5 over, so it's 0 is going in for h. So x plus 1, x plus 0 plus 1. Guys, x plus 0 plus 1 is just x plus 1. So what you end up with is that f prime of x equals -5 over x plus 1 times itself. So I'm just going to square it. Okay, so that's part B. This formula is going to give us the derivative of this original function at any point. So the slope of the tangent line at any point we want. Now for part C, they're asking for us to do the slope of the tangent line at x equals 2. So for part C, f prime of 2 equals -5 over 2 plus 1 squared. That's 3 squared, so it's -5 over 9. Alrighty guys, there it is.